Okay, we're working on the first problem from elastic and inelastic collisions. We have a heavier cart striking a resting lighter cart, and the two have elastic bumpers, so it's going to be an elastic collision. We're not going to lose any energy. So I'll start with an if chart. So we'll call them big M and little m. And big M is initially moving, and little m is not. At the end, this could go a lot of different ways, but what I'm going to guess is going to happen is that that one's going to slow down, this one's going to speed up. Depending on the masses and things, like we could have the original one moving backwards, but the fact that the heavier one is the one initially moving, I'm going to guess that it's going to mean it's going to keep going on. We can always come back and revise this if it's not accurate. So this tells us, or the fact that there's no external forces on the system, tells us that momentum is conserved, and our if chart translates to m, I'll call it u1, we'll just call it u because there's only the one, equals m b1 plus little m b2. So that's true, but it's not enough information to get us both v1 and v2 if we don't know either. So because it's elastic, the total kinetic energy before and after are equal. It's kind of an ugly equation to solve because of the squares. So we'll look at the speed of approach, which would be u2 minus u1. u2 is 0, equaling the speed of retreat, which is v1 minus v2. So now we have two equations that we can solve simultaneously to get what we're looking for. So I'll solve for v1 first. So v1 is v2 minus u, and I'll sub that in over here. So big mu is m v2 minus big mu plus little m v2. So v2, I'm going to keep the v2s on this side and move that one over to the other side, and that gives me 2 big mu. And if I factor, I get big M plus little m on this side, so I'll divide that. Big M plus little m. And this will give me 2 times 2 kilograms times 4 meters per second divided by 3 kilograms as the total mass. This will give me 5.33 meters per second. That's positive, and I called to the right positive because my initial velocity here was positive. So the little cart does indeed move off faster to the right than the big cart started. And now I can just sub that back in. I think I'll sub it in here. So v1 is v2 minus u, which is 1.33 meters per second, also to the right. So my guess up front was right. Okay, so if the collision between the carts lasted this long, what was the average force exerted? So this is, since we know everything about the motion, we know the change in velocity and how long it took, we can use that with Newton's second law. So if I look the force on the 2 kilogram cart, that's the normal force from the first cart, which needs to equal its mass, the 2 kilogram cart's mass, times the A of that cart, which would be m times delta v of big M over delta t. So normal force is m times, we called it v1 minus u, would be its change in velocity, over delta t. So this is just back to old stuff. The only new thing here is that this force is actually not constant. It's changing in time. But if we just take the total time and the total change in v, that gives us the average acceleration, which gives us the average force. So we have 2 kilograms times 1.33 is the final velocity minus 4 is the initial, divided by our 0.12 seconds, and I get negative 44.5 newtons, which means that it was 44.5 newtons to the left. So the force exerted on the 2 kilogram cart is to the left. That's exactly right.